For page 22, label your paper solving equations with complex solutions. So we've talked about complex numbers now, and so we're going to solve some more quadratic equations. So things that you're familiar with, like 5, for example, 5x squared plus 9 equals 0. The only difference is that now we're going to end up with solutions that end up with a square root of a negative number underneath, which means we're going to use that I now. So the directions say solve each of the following equations for the indicated variable. Our first example, number 1, is 5x squared plus 90 equals 0. If you'd like, go ahead and take a moment, pause the video, and actually try this for yourself. It's not that bad at all. And then you can play the video again whenever you're ready. So step 1 is going to be subtract 90 from both sides. And then step 2 is going to divide both sides by 5. When you do both of those steps, you get x squared equals the square root of, is equal to negative 18. At this point, we would take the square root of both sides. And so when we do that, we end up with the square root of x squared. Now remember, the square root of x squared could have been a plus x or a negative x. And the square root of negative 18, I've left that here as is. Now because of that negative, I'm going to split this up into 3 different numbers underneath that radical. And those numbers are negative 1, 9, and 2. I chose 9 and 2 because that's a perfect square. 18 itself is not 1, but 9 is. And so using that rule we talked about a couple days ago from your Algebra 1 days, you would break these up into 3 separate square root symbols. And so now we have that plus or minus x is equal to the square root of negative 1 times the square root of 9 times the square root of 2. The square root of negative 1 we know is I. The square root of 9 we know is 3. So far I have 3i, and then the root 2 I'm just going to leave in my final solution. The plus or minus that was on the left-hand side, I'm going to go ahead and move over that to the right-hand side, and so my final solution is x is equal to plus or minus 3i root 2. And now I'm done. For number 2, same thing. If you'd like, go ahead and pause the video at this point, take a minute, and see what you can do. You'll subtract 9 and divide by 25. When you do that, you end up with x squared equals negative 9 25ths. You'll take the square root of both sides again. We've got that plus or minus on the left-hand side for the square root of x squared, and then the square root of negative 9 25ths. And so now what I'm going to do is I'm going to break that up into 2 pieces. I've got the square root of negative 1 times 9 25ths under the same radical. The square root of negative 1 we know is I, and then the square root of 9 25ths is going to be 3/5. There should be a 5 here, sorry about that. So final answer, once I move my plus or minus to the right, is x equals to plus or minus 3/5 I. And then we've got 2 more examples here, 3 and 4. For number 3, I would suggest pausing it, trying number 3, getting as far as you can go, and then unpausing it. So for number 3, we've seen something very similar just a few days ago when we were solving by taking square roots of both sides. That was on page 19, where you solve quadratic equations by taking square roots. And this is very similar to that process. Please don't FOIL this out. It's a terrible idea. You have an x sitting right here that you're trying to solve for and isolate. So there's a plus 4 to move, there's a square to move, a times 3, and add by 20. And so first thing we're going to do is we're going to subtract 20 from both sides. And so you get negative 52 minus 20, which is negative 72. Now we're going to divide both sides by 3. And so now we end up with x plus 4 all squared equal to negative 24. At this point, you'll take the square root of both sides. Don't forget your plus or minus on the left-hand side when you do that. And then on the right side, you're going to take that negative 24 and you're going to break it up into 3 pieces, negative 1, 6, and 4. Once you take the square root of each of those individually, you're going to get I and 2 for the square root of negative 1 and the square root of 4. The square root of 6 you'll leave in the problem. And then we've got on the right side plus or minus 2i root 6. You'll subtract 4 from both sides so that your final answer is negative 4 plus or minus 2i root 6. Number 4, go ahead and pause the video, see how far you can get on your own. So step 1 is going to be subtract 169 from both sides. And now since there's nothing in front of the parentheses, you can go ahead and take the square root of both sides. Once you do that, you end up with, on the right side, -1 times 169 under a radical. On the left side, don't forget that plus or minus in front of the 3x plus 5. I'm going to go ahead and take that 169, take the square root of that, that's 13. The square root of -1 is I. And then that plus or minus that was on the left, I'm going to go ahead and move it to the right-hand side. Once I do that, I'm going to subtract 5 from both sides. And then I'm going to divide both sides by 3. So my final answer then is x is equal to -5 plus or minus 13i divided by 3. I could break this up into two separate fractions if you want. This is a technique we'll use later on down the road, so I'm going to go ahead and just show it so that you're familiar with it. So I divided both of these by 3, -5 over 3. The plus or minus remains in the middle, and then the 13i divided by 3 is going to be next. So the final answer is x is equal to -5/3 plus or minus 13i divided by 3. And that's it for this page. For both of these, or all of these actually, I would always suggest that you check your answer. With complex solutions, it works the same way that you would with real solutions. So you would just plug x equals, I'm going to do number 3 and number 4 because these are a little bit more complicated, but number 1 and number 2 would work the same way. So for number 3, in order to check my answer, I'm going to take this -4 plus or minus 2i root 6, and I'm going to plug it back into the original problem. And so where I see an x in the original right here, I'm going to plug that in. I put it in blue and color-coded it. And then I've got the plus 4 there. I've got it in parentheses, squared. I put the 3 back on the outside, the plus 20, and the equal to -52. So I'm just checking to see if this is a true statement. And so what I'm going to do first is this -4 and this +4 are going to cancel out. Now you'll notice I went ahead and dropped my plus or minus. The reason I did that is because there's a square here. So it really doesn't matter if there's a plus and then I square it, or if there's a negative and then I square it. In both ways, I'm going to get a +4. And then the square root of 6 times the square root of 6 is 6. And then I squared is going to become, I with an exponent of 2 is going to become I squared. So you'll notice the 2 I multiplied, I raised each of these to the exponent of 2 and for everything that's in that parentheses. And all of these are separated by multiplication, so I'm allowed to do that. Now I have 3 still on the outside and the plus 20, so then 3 times 4 times 6 is going to be 24. Just kidding. 3 times 4 is 12, 12 times 6 is 72. And so then I squared, remember that's a square root of -1. And then you're going to multiply by the square root of -1 again for the exponent of 2, and that becomes -1. 72 times -1 is going to be -72, plus 20 becomes -52, so I know I've got the right answer. Number 4, it's very similar. Some of the steps, a few things are a little bit different, so I wanted to make sure and check this one so you could see how to do that. So same thing, I'm going to plug in this answer, the blue answer, back into this original x. So you'll notice I've color-coded it here and done that as well. And so from here I'm going to follow my PEMDAS. With this parentheses right here, I have to multiply by the 3 first, so that when I do that, the division by 3 and the multiplication by 3 will cancel each other out. So all I'm left with is my numerator, -5 plus or minus 13i, and then I've got this plus 5 here as well. From here, this really works just like number 3 when I was checking it. So it's very similar. I'm going to take that -5 and that +5, and I'm going to cancel them out from each other. And again, I dropped my plus or minus because I really don't need it because of this square symbol right here. So I went ahead and just got rid of it. 13 squared is going to be 169, and then I've got I squared as well. I squared is going to be the same thing as -1, so I've got 169 times -1 plus 169. When you put those together, you end up with 0, so you know you've got the right answer. I would encourage you to do the same up here, just to check and make sure that you know how to do that. And I would always do this for checking your answers, but you don't have to do it on this page for numbers 1 and 2. And that's it for this page.